Next, I'd like to introduce Kevin Phillips. He's one of our awesome JavaScript developers at Bitovi, and he's a core contributor to CanJS. Kevin's going to show us some new CanJS APIs that are built on the custom elements native APIs and how they're shaping the next version of CanJS.
As Jason mentioned, my name is Kevin Phillips. I'm a member of the CanJS core team. Today I want to talk about the future of CanJS. So for anyone that doesn't know, CanJS is a collection of JavaScript libraries that help you build CRUD apps in fewer lines of code. It's kind of the tagline there. So CanJS 5.0 was released nearly a year ago. I looked, it was like July 2018. Today I'm going to talk about some new APIs that we've added in CanJS 5.0 and what we're working on for CanJS. So for 6.0, we're focusing on a few things. Creating improved observables, providing tools for creating custom elements, and then removing node lists, which is long been a source of bugs in CanJS. So I'll give you this basic example. Unlike Adam's earlier example, mine has more than one counter. So we'll take a look at this. This is using the new APIs we're working on to create a list of counters. Let's dive into the code. So here's the four new APIs that we've added for working with elements, observables, and types. We'll take a look at each of these. So define object lets you create observable objects using classes. Define arrays available also for creating observable arrays. And then can type is available for working with types. Lastly, stash define element is for creating class constructors, and you can use these to build custom elements. We'll dive in more to each of these in the next slides. And here you can see the example. Notice how many counters I have, way more than one. Cool. So I'm going to go through, give an overview of all the improvements we've made in these new APIs over our previous observables. So I'm going to scroll through each of these for time. We'll dive into talk about each of these in the coming slides. So the first benefit of our new observable APIs over define map and define list is that we're just using normal JavaScript classes. You create your observable using JavaScript's extends, create a class, extend define object. Instead of using our own inherited system, we're just using JavaScript's classes. This really reduces the APIs that you have to learn to get started with CanJS. You can still create well-defined properties like you could with CanDefine, can map define in previous versions of CanJS. Use this static define property to keep your definitions separate from your class's methods and getters and setters and that kind of stuff. All right, so we've really tried to simplify how you define properties with these new APIs. I'm going to fly through these because there's a ton of them. The first thing is we really wanted to make it easier to make asynchronous getters. So previously, you just used a getter and had some number of arguments that you passed to that getter to determine whether or not it was async. Now we've separated these. You've got normal getters for getters, and then this async property for asynchronous getters. Async properties can return a promise, and when the promise resolves, the property is automatically set to the resolved value. We no longer have magic strings for types, like you used to have type Boolean as a string, type string as a string, type number as a string. Now you can just use the native constructors for those types. We also don't have a difference between lowercase value, like lowercase type, uppercase type anymore, and the same thing for lowercase default and uppercase default. Everything is just lowercase. Really remove some confusion that a lot of people have. Since we don't have those magic string types anymore, you can now use primitives in this shorthand default syntax. So you can, if you want to create a Boolean, you can just default it to false like this, or a string or a number, whatever you want. We can also have functions as defaults. This is great for renderers. We often have like you want a default renderer that you use and allow someone to pass in a different renderer if you want to, so that's nice that you can do that. We've got this get default syntax for default objects. This lets you create objects as a default value that will not be shared across multiple instances. And then the last improvement is that enumerable and serialize are separate, two separate properties. The next big improvement that we've made is expando properties are now observable automatically. Let me explain what that means. So we create this to-do class without any defined properties. We set up a binding on some property that doesn't exist, and then you can just simply set that property, and that will trigger the event and trigger this event callback. Previously, you had to use a special method for setting these expando properties. You don't have to do that anymore. You can just set it like a normal property. Cool. The next big improvement that we made is types are now strict by default. A lot of people have been asking for strict types for a long time. So let's talk about what that means. So you can define a property here. It can be set to a number. If you set it to something that's not a number, it's going to throw this error, which is nice. That's kind of what people expect when working with types, is they expect them to be strict. If you don't want strict types, we allow you to use the CanType package to create types that aren't strict. So we got type.maybe, type.convert, type.maybe convert. We'll talk about these. So type.maybe lets you create a property that can be that type, or it could be null or undefined. You can see here this type.maybe and pass a string. It can be a string, it can be null, it can be undefined. If you set it to something else, it throws an error. Type.convert will convert whatever you pass into the type that you selected. So type.convert with the string will convert anything to a string. A string, null, undefined, a number, all of these all get converted to strings. And then lastly, maybe convert allows you to have something of that type, allows null, allows undefined. If you pass something else, it will convert it. This is kind of the behavior that CanDefine had previously. All right, lastly, we support required properties now. So you can mark a property as required here in this define object. You can create an instance. If you have that property, initialize it with that property, it works correctly. If you try to initialize without that property, it throws an error saying that your required property is missing. You can do the same thing for elements. Mark this person as a required property. Then if I create an instance of that element with a person, it works. If I create an element without a person property, then it's going to throw an error. All right, so now let's talk about some of the improvements to components. So the benefits of stash define element over can component. The biggest thing is that we're creating real custom elements, and then we'll also talk about the new lifecycle methods and lifecycle hooks that we're providing. So what does it mean to be a real custom element? So here you can see we're working with this counter example. I know it's only one counter this time, but that's okay. You can interact with it normally, and you can also interact with it. So Chrome gives you this $0, lets you get a reference to the element that's selected. So you can see here I'm calling the element's methods. I'm looking at its properties right here in the console. So you can interact with this thing natively in the browser. And the big thing here is that there's no difference between the element and the element's view model. Its properties, its methods are directly on the elements. You can just interact with it like you would any other element. Another big benefit of this means that it's much easier to integrate custom elements into your application, no matter what JavaScript framework you're using or backend framework. If you're using PHP to render your HTML, you can integrate custom elements really easily, no matter what. So here we've got the code for that previous counter example. Down here we have a React component. Obviously in React you can work with HTML elements, so we can do the same thing with our counter. We can render our counter here inside of React. Using a ref in React, we can easily access the counter elements, properties, its methods, and whatever we want to do. React is probably actually the hardest JavaScript framework to integrate a custom element into, and it's still, you can see there's still only a few lines of code. And here we can see this is a demo of that React counter. You can see here our normal counter up here, and then down here this is React JSX is rendering this, and this all works together. Pretty nice. All right, so another big improvement of stash define element is the improved lifecycle hooks and lifecycle methods that we've created. We really wanted to make it easy for you to integrate other code into your elements and really make it easy to test your elements. So we'll talk about these. You're not supposed to be able to read this, don't worry, if it's super tiny. All right, so here we have a timer example. This basically counts up every second. It increments this time property by 1. So the big hook that we've created, often in applications like this or elements like this, you need to run some code when the element is put in the page. So we've provided this connected hook that gets called when the element's in the page, hopefully to make this really easy. For people who are familiar with custom elements, this is called by the connected callback, but we didn't want you to have to call like, know to call super.connected callback or whatever to make this work. So we provide connected so you don't have to know about that. you can return a teardown function, and we'll call this when the element is removed from the page. It makes cleaning up after yourself really easy. There's also a disconnected hook for things that you need to tear down that don't have any setup code. It's a little bit less common, but we have that as well. All right, that was the disconnected and connected hooks. Now we'll talk about all the lifecycle methods that are available. These are designed to make it really easy to test your elements. The first one is the initialize method. So you can initialize an instance of an element with some initial property values, and this lets you sets up all your well-defined properties and lets you test your properties and methods. You can see here we're accessing the time, seeing it's correct, calling some methods, testing that things are set up correctly. There's also a render method. You call this the same way, pass in some initial property values. This lets you test the same thing. You can test the properties, methods, but you can also test the view. So we can see here in our timer, the inner HTML has been rendered and everything is set up. You can still call methods and see that the inner HTML updates correctly. You can also, check its child elements and all kinds of stuff, however you want to test the view of your element. Lastly, we've got the connect method. Use this the same way, call connect with some initial property values. You can use this to test properties, methods, the view, and also that connected hook that we saw previously. So here we can see that check the inner HTML, it's been running for 5 seconds. We wait a little bit of time and see that the time is updated and then the inner HTML is updated because that connected code that was running is updating that time for us. One thing to note is with using any of these, initialize, render, connect, you don't have to worry about calling them in order. If you just want to call connect, connect will call initialize, then call render for you. It'll handle all of that lifecycle management. All right, I know you're probably saying to yourself, when can I use all of this? So everything I've shown so far is available now in CanJS 5.x. These are ecosystem packages, so it's possible that there's going to be changes, but definitely try these out. Let us know what you think. These will probably, the plan is to upgrade these to CanJS Core in 6.0. So let's talk a little bit about what is left before 6.0 will be released. The big thing is that we want to finish removing node lists. Like I mentioned before, this is a long-standing source of bugs in CanJS that have to do with how elements are cleaned up in what order. So children are removed in the correct order from their parents and that kind of thing. Another big thing is we're going to iterate on these new APIs and fix bugs. We're using these on a client project now, and we're going to work on updating our example apps and all that kind of stuff to use these new APIs to iron out any last-minute bugs. And we're also working on some code mods. These are basically going to let you convert a can-define map into a define object, convert can component to a stash define element. These are primarily for us to use on our own guides and documentation. You won't have to, if you have an existing app, you won't have to change all of your components to be stash define elements. We're not dropping support for anything. Can component, can define will be around probably forever. All right, what comes next after 6.0? So 2 big things, elements for CRUD operations, and then different view layers and state management solutions. I'll talk briefly about these. So CanCRUD, this is a project that I'm really excited about. We're going to use these new custom element tools to build custom elements that are really useful. We're going to focus on making CRUD operations really easy, since that's what CanJS is all about. So the idea is that you'll create your observable type, and you can pass it to one of these custom elements that CanCRUD provides. And CanCRUD will figure out some information based on the definitions, the property definitions that you have, and do things that make it really easy to do CRUD operations. So let's take a look at these. So here's an example of what a mock-up of what the CanCRUD might look like. So it'll render out, say, a list of to-dos, and then a form for creating new to-dos. Big part of most of our applications are creating items and then displaying lists of items. So something that we want to make really easy. So the next thing is that we want to do some experimentation with different view layers and state management solutions. People have been asking for JSX forever. JSX is great, and a lot of people really like it, but now there's a ton of other really good solutions for both of these. So lit HTML is awesome too, for state management, hooks, reducers, RxJS, a lot of things that are really popular. We want to experiment with these different things, figure out if there's a good way for us to let people use them inside of CanJS in a way that's performant and cohesive.